scale factor of 3. It says, what properties does your scale drawing share with the original figure? So I'm trying to make sure I know what properties shared with the original figure. And so there are some really important parts and pieces to this. Two properties in particular. So first thing, corresponding angles are congruent. Second thing, corresponding lengths are in proportion and then there's a few more ideas that we really need to cement. The scale factor is the constant of proportionality. So constant proportionality basically just means that no matter what I'm looking at when I measure one of these three sides, that its corresponding side is exactly the relationship with that scale factor. And then orientation of the drawing does not change. And what they really mean by that is if I was going in alphabetical order from D to E to F back to D again, you notice that this is a counterclockwise rotation. And if I were to look at D to E prime or D prime to E prime back to F, notice that the arrows are also going in a counterclockwise rotation. And so ultimately that's what they mean by orientation. Okay, one last example and then one thinking problem. Use construction tools to create a scale, but this time my scale factor is 1/2. And so I would pause for a moment and think to myself, what is this 1/2 business? How would that affect the drawing? And so I maybe write this down. So far what I've noticed is that it got bigger when it was a 2 or a 3. And we can sort of generalize the results of the scale factor that if R is greater than or equal to 1, or greater than, not equal to, but just strictly greater than, the result is an enlargement. If the R value, or the scale, is between 0 and 1, this results in a reduction of the pre-image. Okay? And so now I'm looking at this and it does say 1/2. Well, I think to myself, how could I get half of this? And if I'm sort of working at it systematically and I'm thinking to myself, well, how could I really do that? Right now I notice that this is 4 and I really want to be a half. Half of 4 is 2. So if I'm splitting this in half and that means this segment is the same as that segment, what I've noticed is that this would end up being my midpoint. I also recognize that a midpoint is really just a different way to say that I've bisected my segment. Bisector triggers a memory that I could work with a perpendicular bisector. And that perpendicular bisector is a good tool because I know how to find one of those, so I just split the distance from y to z, make sure I'm a little more than half. And then I can draw my line. And notice it goes right through that 2 spot. And so there's my point. If I anchor myself on z or y, that'll tell me exactly which segment I'm going to bisect. So I'll go with z. And so this is going to be y prime. And so I need to do one more perpendicular bisector. And so now I have this spot right here, and that would be my x prime, and then the connection between y prime and x prime, boom. And now I have a scale factor of 1/2. I'd also like you to notice kind of, some people might assume that if you have a scale factor of 1/2, the area would also be 1/2. And I want to caution you not to assume that, because that's not necessarily true. And in fact, if I kind of just create a couple triangles, let me make sure I'm doing this right, you'll see that you end up actually with 1/4 the area. So 1/4. And so the relationship between the areas is the scale factor squared. The last question I have for you is this one, where it says a scale factor of 1/4. And I'm going to leave that as a challenge to you to think, how could I do a scale factor of 1/4? Okay, that's your challenge as you go.